In module 3, since I'm running short of time, I'll be doing only a few questions which have been repeated in past year question papers, out of which key IP advantages is one main part. MQTT is there, CoAP is there, 6TISCH is there, adoption and adaption, and then IOT transport is. So what is IP addresses? IP address is also called as internet protocol. What happens in internet protocol is it's an address which is given to your computer. So what happens is you have to communicate on the internet, communications to happen, you give an address to your internet service, that is your internet that you're using. So every device of yours will have an internet address, that is your IP address it'll have. So through this is how you communicate through emails, through world wide web, and getting the data, accessing the data through internet. So we have to find out what are the key advantages of IP address. So what happens is that here in IT and OT, there's lifetime underlying of technologies and products. So we're using IP architecture as it is demonstrated its ability to define layered architecture. It's been around for more than 30 years, and it is very effective, and then it can be integrated and used during large evolutions. So what you're doing is you're maintaining for any number, so it is used for many number of devices till today, and then there are mainly IPv4 and IPv6, two types of IP addresses. So what you're doing is you're finding the advantages of IP and explaining here. So first one is your open and standard based. So what happens here is you have a large set of devices, and then your IP addresses have to be allocated to that. So what you're doing is your large set of devices will have different functionalities, and then they'll have different interoperabilities, interchangeabilities, securities, management. All this has to be taken care of. So what you do in this is that uh, since there are standards for developing organizations in the Internet of Things definitions, so you have for everything you have standards, right? Set standards according to which you have to develop. For Internet of Things definition, what happens is you have frameworks which have to be standardized, applications that has to be standardized. So similarly, so you use role of Internet Engineering Task Force, that is IETF, as a foundation here. So you're using them as a standard to find IP protocol suite. Then you have your second part, that is your versatility. What you're doing is you have a wide range of products that has to be that the IP has to be applied through. So what happens is even if the physical and data link layer, you use it for Ethernet, you have IP address for devices which are connected to the Ethernet, devices which are connected to through the Wi-Fi and cellular data. So all of this uses IP address, and we've seen that it's been able to cope for the past 10 to 20 years of our lifetime. And then we have a layered architecture which enables any type of physical and data link layer, which also gets integrated in the IP addresses. So you have ubiquitous, which means that it is found almost everywhere. So what happens here is that you have, like I said, they're integrated into dual, that is IPv4 and IPv6 IP stacks, because you used to have IPv4, and then once it gets saturated you need to move on to the next level, right? So they came up with IPv6. So this is a from general purpose computers to any lightweighted embedded system also, using the IP addresses. So what we've done is as most of their updates, okay, they've been on IPv4 at this point, and then they're still standardizing IPv6. So IPv6 is a newer model. So so many of your devices which have already existed is on IPv4. So those gets enhanced as time goes on. So then you have scalability, that is your millions of public and private devices also use your IP. IP infrastructure nodes. So they have been operational for previous year. I mean, for so many years in the past. So they add huge number of things to private and public infrastructure. Um, they are manageable and highly secure. So what you're doing is the main point of having a protocol is that to maintain security and then to have a proper set of rules to govern it. So what you're doing here is that you're as it is safe. You have had any many such things as financial and IP is also used in financial and defense networks. Nowadays they've started to use for every simple thing, so that it is made the information is made private and then is protected. So even for voices and videos that are sent over the internet, we have open IP standards. So what you do is next is consumers market adoption. uh, Under consumers market adoption, we've seen that if you keep IPs only for mainframe computers, which are rarely seen nowadays, it'll be difficult. So what you're doing is you're seeing what is required for the consumers in the market. That is, they use now for broadband and wireless infrastructure, for mobile wireless infrastructure they need it, right? So even our phones have basic IP protocols which are run on it. So you have common protocol that links IoT and the consumer space to these IP devices. Then you have the innovation factor. That is, instead of keeping the IP address as the IP protocols maintained however it was 10 to 15 years ago, you've what they've done is they've enhanced it by ranging it from file transfer to email to world wide web to e-commerce, social networking, mobility, and many more. So what happens is the computing evolution of PC and mobiles have moved from mainframe also to a much larger scale. So IoT application layer protocols. What happens here is you have two main popular protocols, which are CoAP and MQTT. So these are the lightweight protocols that are used in the network. So what you have is you need a structure for CoAP. So what you have here is CoAP, MQTT. This for both CoAP and MQTT. CoAP, MQTT, UDP, and TCP. Okay, so you just draw it as 4 sections. Then you have IPv6, 6 low pan. Then you have 802.15.4 MAC layer, and then physical layer. So what you have here is these are naturally on top of the IoT stack. These are based on 802.15 mesh network, while there is a few exceptions that CoAP deployed over UDP and MQTT is deployed over TCP. That's where we take a further look. That is, you have CoAP. For CoAP, the full form of CoAP is Constrained Application Protocol, which results in IETF, that is Internet Engineering Task Force, that from Internet Engineering Task Force constraints that RESTful environment, that is core working group of generic data. So what happens is you have frameworks that define simple and flexible ways to manipulate the sensors and actuators. So they give you a core of working groups that has been given. So that includes RFC, that is RESTful environment of core link format. RFC 7252. This is the constraint application protocol layer. This is CoAP. And then you have RFC 7641, that is observing resources in CoAP. 7959, that is blockwise transfer in CoAP. Then you have 8575, that is guidelines for mapping implementations, HTTP to the CoAP. CoAP messaging model is used mainly for exchanging messages over UDP, however the endpoints between the endpoints. including the secure transport protocol datagram. The working group in the study alternative transport mechanism, including TCP, secure TLC, and so on. You have short message services, which are defined over Open Mobile Alliance for lightweight machines. So the RFC 7252, that is your CoAP. What happens over here is it gives you more specific endpoints and how to give provisional keys. That is, you have a 4-byte header. Okay, in this you have version, token, you have version, type, token, code, and then message ID. The token length is optional, and then options, payload, and then you have your values. So you have to write this in different words. That is your short fixed length header field, a variable length token field of 0 to 8 bit, then operational field if necessary, then the payload field. So this is the CoAP message format. So you just need to buy out the CoAP message format. And then you have to write the message format that is alternatively used for the CoAP. So what happens here is, as we saw over here, VER. This symbolizes the version that identifies the CoAP version. Then you have type. That gives you the type. If it is a conformable, that is a con, or non-conformable, non. And then acknowledgement ACK. And then reset, that is RST. So con and ACK are highlighted more. So what happens here is, next you have token length. Token length, what happens is it specifies the size, that is 0 to 8 bits. It is your token field. Then you have your code. So this code, what happens is it indicates the request method. So it is either get or get the request method from the response code. You give your code name over here. You give your code name over here. That is to call the core working group. And then you have message ID. What happens in message ID is that it is used to match acknowledgement and reset for message types, con and non message types. So acknowledgement and con, that is your conformable or reset and non-conformable message types have to be matched. And then you have token, that is your token correctly. TKL is your token length. So you have token, that is the length is with the specified by TKL, the correlation, requests and responses. Now you had given the length of it. Now you're getting the whole token that it correlates to responses and requests. Then you have options. So what happens in options is it gives you the option number length. It gives you the option number, the length, the option value, the capabilities which are provided by the option field, and request and proxy functions. So you have you have payload, that this carries the CoAP, that's CoAP application data. It contains your data. The payload contains your data, and then this field is optional, but in the present, but when it's present, a single byte is of 1s ones. You have a single byte of all ones, 0 into f that precedes the payload. The purpose of this byte is to delineate the end of options field and beginning the payload field. So what you're doing is you're using it as a blank space where you can draw a clear border between your options and payload field. We need to know that our CoAP is generally runs over UDP, which makes it a little bit of a reliable transmission for messages when CoAP header is marked conformable. So what happens is you have basic congestion control with default timeout and simple stop and wait retransmission, which happens through the message ID. So if this is If a request of response is tagged confirmable, then you either get an acknowledgement or the rejection of message of the same. So what happens here is you send a confirmable message of 0 into 47 with get temperature. You have a temperature sensor, that is your IOT server. So it acknowledges with the same thing. You give the same values, and it acknowledges you with the temperature. So the CoAP message ID will be 0 into 47 with the same ID which is being provided for us. Then you have MQTT, that is your message querying telemetry transport. So what happens here is you have a large number of sensors from the data, and then from central servers, and then it's typically oil and gas. So what happens here is they used implementation of machine querying telemetry transport. So you have to consider hash, and they've given an example. So what you're doing first is you're having a sensor, that is your MQTT client, that is your publisher subscriber model. Okay, so you have a publisher and you have a subscriber. So you have a message broker that sends it to your clients. So what is happening here is an MQTT client acts as a publisher to send the data or information about humidity or temperature. Okay, and then to an MQTT server. This is a server which acts as a broker. So what happens is that the client on the left side of the, so you have MQTT clients over here. So these, they accept the network connection, and then messages such as the temperature data. They get the data from the publisher. It handles subscriptions and unsubscriptions process also, and then the application on the right application is there on the right side. So you use the data which is got by the sensor on your right side. So these information are generally which is got from this publisher are well known. You have a great collection of networking applications like Twitter which use this. With MQTT, that is your messaging querying telemetry transport, what happens is that your subscriber, that is your, it's like using a wildcard entry. So for some specific data of information from a publisher. So what happens is you can skip all this, and then you have to write that the benefits of decoupling is that MQTT message broker ensures that the information can be buffered and cached. They can be buffered and cached in case of network failure. That also means that publisher and subscriber do not have to be online at the same time. Okay, so then what happens is you're giving its message format. So you have a message type, you have DUP. This 1 byte. Over there it was for coax, it was 4. Here it is 1 byte. Message type, dupe, QoS, retain. Then you have remaining length. Then you have variable header, and then you have payload.